This chapter, guys, sets the kind of forefront for us to work through a bulk of the rest of the course, okay? We're going to start developing relationships that exist between parts of individual triangles, and then also develop relationships that are existing between separate triangles. If we can really hone in and understand all these relationships within triangles, as I said last week, we can then kind of put those together to develop relationships in other shapes, okay? What we talk about today is more of a notation type thing, vocabulary type thing, in regards to how we're going to identify and talk about congruent figures, okay? So today is talking about just all kinds of shapes. Could be, congruent quadrilaterals, could be congruent any polygons, pentagons, octagons, whatever, however many sides we want. And we'll learn an understanding of how we identify congruency within shapes and what it means for us. And then tomorrow and the next day, we're going to kind of step back and say, okay, now that we know how we do it collectively for all shapes, let's just focus in on dealing with just triangles. Okay? There will be some triangle stuff today, but collectively today, the arguments that we make today are true for any number of sided figures that we deal with. Okay? We've talked about how congruent figures, congruent shapes, maybe is the way that we referred to it earlier at one point. It just means that figures or shapes have the same size and are the same shape. Okay? So a triangle can only be congruent to a triangle. A quadrilateral to a quadrilateral, a pentagon to a pentagon. Okay? Circle to a circle, that kind of thing. Okay? Obviously, a triangle cannot be congruent to a quadrilateral because one of them has 3 angles, one of them has 4 angles, and that means the shapes are different. Okay? So the way we name congruent figures is important. And the way we name anything in this course is important. And there's going to be structure or guidelines in how we name or choose names for congruent figures. But it's important because every time I see the statement that incorporates the congruent figures, okay, and then essentially the naming of these two figures, it will tell me all of the congruencies that I need that the picture would provide me as well. I kind of told last class that the higher you get into math courses, a lot of times the less kind of descriptive they are in textbooks and stuff like that with pictures. My college geometry class, if I go through that textbook, there's not a single picture in it. Okay? But a lot of these relationships are explained and used and practiced with exercises and stuff like that. So everything that we say in text, the way we write it down by hand, should say the exact same thing that our pictures say. Now, we like to use pictures because this is the first time we're seeing this, and we don't have all that great of a background with this information, so the pictures are going to help that. You've heard the phrase, a picture says 1,000 words, right? So it's going to be a lot easier for us to use pictures and decipher information from that. But at the same time, the way we write things down by hand should verify or back up what our pictures say, and vice versa. Okay, our picture should back up what our text says. So we should be able to do all this stuff with a picture or with just text, and still get the same result, same information. So just want a quick exercise here. I want to talk about these two shapes. These two shapes are indeed, I just cut and pasted them. They're the same shape, right? So if I take the light blue one, it's going to lay right on top of the dark blue one, right? Okay. They are the same shape. They're ultimately going to be congruent. Okay. What I want to do is I want to go through and talk about what we mean by corresponding. We said corresponding in regards to parallel lines last chapter. And the word correspond is going to mean the same thing here. Okay? When we talked about correspondence in the last chapter, it was essentially, if I were to take one line and slide it up my transversal, look at where the angle kind of travels to. Where does it match up to? If I look at angle X, what does it match up to? Angle A, right? Okay? So I'm going to write that angle X corresponds to angle A. Okay, I just use a little arrow for where it corresponds. Now, what would Z correspond to? Z. And what would Y correspond to? Okay, that's pretty easy, right? Now, this is kind of easy because the way that these two figures are kind of orientated to one another is that this one, all I did is I kind of cut and pasted it, but I just slid it over, right?
Because remember, the word for that is just a translation. Okay. It gets a little bit more difficult to see what lines up and what matches up when the shapes are not pure translations, right? Does that make sense? It's a little bit harder here to see that maybe this angle down here at the bottom X matches up with A there. Okay? And we'll talk about how we do that eventually. But we get these correspondents. Okay? Now we'll look at the side lines. Okay? If I look at XZ, segment XZ, what is that going to match up to? AC, good. Okay. What about XY? AB. And then what we got? ZY is the last one. ZY is going to go to CD, right?
That's pretty easy, correct? Okay, being able to see what matches up. All right. Now, if my overall goal, guys, is to show that these shapes are congruent, okay, I need to be able to do this. I need to be able to go through, and even though they correspond, I would then need to know that those two angles are indeed congruent. They're the same angle. And then I need to show that these two angles are congruent, and the same for these two. I need to show those three pairings of angles to be congruent. That's not enough for us. Okay? To show congruency amongst two shapes, we need to do all the angles congruent, all corresponding angles congruent. And then I need to come over here and I need to show that all corresponding segments are congruent. So in a triangle, if I want to show two triangles congruent, I have to show those 6 individual congruencies first, and then the result of those 6 individual congruencies is the fact that the two triangles are indeed congruent to one another. They're cut and paste images of one another. Does that make sense? Okay? But I need those 6 things. If this was 2 quadrilaterals, I would need 4 angles congruent to 4 angles and 4 sides congruent to 4 other sides. Does that make sense? So I would need 8 things. If it was pentagon, I need 5 angles congruent to 5 angles, 5 sides congruent to 5 sides. So I need 10 things. All right, so I kind of, however many sides I have or however many angles I have, I need double that in regards to individual congruencies to show the same, or show the shapes are congruent shapes. Okay. Now the reason why, let's say that I kind of alter this, and let's just say I've got a quadrilateral here. Let's just put that point as W. So we've got this quadrilateral here. Why is that shape never going to be congruent to ABC? It's because if this is the idea, I need to say angle W corresponds to what over here? And there's nothing that it corresponds to, right? So there cannot be a congruency there. So a quadrilateral and a triangle are always incongruent because they're not the same shape. Does that make sense? Okay. When we talk about congruency, and I'll put this up here in a moment in another slide, but this here, this provides us, when we look at the angles being congruent to one another, that stuff provides us the fact that we have the same shape. All right? We saw just a moment ago when I put W up there that one of those shapes was not the same as the other, right? Okay? So if I can verify that I have angles that all correspond and they're all congruent, that's gonna give me the components of my definition that was referring to the same shape for congruency. If I can show those congruencies, those are segments, right? The segments provide me the same size. Okay? Think about this. If I think about these two triangles, right now, assuming that those two triangles are congruent, we have the same shape based off these angles compared to these angles. We have the same size based off of these segments compared to these segments. But if I do something like this, okay, now let's say the angles, I kind of messed up the angles a little bit, see if I can fix them. Actually, let's see. I wonder if there's a dilation tool here I can use. Size. Let's just say that when I changed that I was able to keep Angle A, the same as angle A. Angle B, same as B, and C is same as C. Obviously, they're different, but does that verify that I have the same shape? Do I still have 3 angles compared to 3 angles? But do I now have 3 segments congruent to 3 segments? No, I have different segment measurements now when I compare corresponding sides. So now I would have a different size, correct, between the 2 shapes, and now they're not congruent, obviously, right? Does that make sense? So the same shape dictate or is dictated by the number of angles we have, essentially, and the same size is then dictated by the congruencies or the lengths or the equality, I guess, of the segments that are making up that shape. Okay? Is that all right with everybody? Okay. Excuse me. What? All right, and that's what this slide here says. I don't know if you need to write that down, but when congruent triangles are existing, that means they have the same shape, and that is brought on because they have the same number of angles and their corresponding intercongruent. If we have congruency among shapes, in this case triangles, that means they have the same size, and that is brought on upon the fact that the side lengths are congruent, or the side lengths all have the same measurement. Okay? So those are the kind of the things or the components that force our definition to be written as same size, same shape. Okay? Angles force the shape, side lengths force the size. Okay? Or the segments force the size. All right, so I want to, before we get into the rest of this PowerPoint, I want to show you kind of what the PowerPoint targets, but show it to you in kind of a dynamic way. So I think it's a little bit easier to see here what we're trying to do. When we name figures, guys, and we're going to try to name congruencies here. I want these two, I want the red one and the orange one to be identified as being congruent to one another. Okay, now, when we do that, there's a structure of appropriate ways to identify the congruency. Okay, but within that structure, you have a little bit of leeway. Okay, you have a little bit of ability to maybe alter the way you write it compared to the way somebody beside you writes it. Okay, if I look at that first red figure, I've named it A, B, C, D, E, F. Okay, all I did was I chose a starting point, and I just chose A. And then I have an option. When I choose a starting point, I have an option to either go that way or that way. Okay? I chose to go that way, right? And all I do is I write down the next vertex that I would pass through as I'm trying to trace out this shape. I go to A, and the next vertex would be B, right? And the next one would be C, next one would be D, then E, and then F. And then eventually, this thing is kind of cyclical. I mean, it's going to get me back to A, so then I can go to A. Does that make sense? Okay? You just don't write A again. All right? Just know that the way that we structure it, F will get me back to A next. So that's an option. That's the way I decided to name it. But somebody could have went from A to F. Does that make sense? They could have named it A, F, and then went to E and D, C, finished at B. Is that all right? So there's 2 ways that I could have named it starting at A. There's nothing that says I had to start at A. I could have started at B. How many different ways can I name it if I start with B? 2, right? I go B, A, F, E, D, C, or I go B, C, D, E, F, A, right? Well, there's 2 ways that I can name this figure starting with B. There's 2 ways I can name it starting at A. There's 2 ways I can name it starting at C, D, E, and F, right? Collectively, there's 12 different ways I can name this figure. And that's the problem. If there's 12 people in here, this is a homework question, and I gave it to you, you came in and you named it. Every one of you could potentially have started with a different name for that first figure, right? And if I name that first figure, that then dictates how I name the second one, all right? Because the name itself, I should be able to look solely at, here. I should be able to look solely at this thing here, because there's going to be some letters over here in a moment. I should be able to look at just that, and it tell me the exact same thing that I gained from looking at just that. Does that make sense, everybody? Now, when I look at just that, the argument is, and this is what people want to do all the time, is they want to take this one here, and they want to lay it right on top. Well, do they lay right on top? No matter how I try to match these up, they don't lay right on top by just taking one and sliding it over to the other one. They're doing what we call just a translation, okay? What I get a lot of people want to do, for some reason, say, well, B, that's going to match up with it's kind of the left corner. Maybe it matches up to V. And then they say, well, A is the top point north of maybe my horizontal. So then they say U and A should match up. Does that kind of make sense what they're doing there? That is totally incorrect. And hopefully you see now the way I got this picture kind of developed that makes sense why that's not correct. But sometimes your pictures are so similar. Maybe if I do, something like that, now maybe it could be kind of argued that B would match up with V, right? And A with U, F with Z, E with Y, X with D, and W with C. Does that make sense to everybody? Because those shapes are really very similar looking. But if we kind of do this and realize that the only way that they're going to match is if we do kind of a rotation after we slide them. Does that make sense? Okay? Because even if I still slide these, they're not going to match. You see, there's still a little bit of kind of discrepancy on the way they match up, right? Okay? So the way that we do it, and I'm going to go back to the first shapes that I had set up, because I do want to see that kind of more drastic difference. But I named this one A, B, C, D, E, F. So we got to be able to name the second one based off of this name, meaning that when I go back to, when we went to this thing here, and we had A correspond to X, right? Well, that's because A was congruent to X. Does that make sense to everybody? We wanted B corresponding to Y because B and Y were congruent. That's what we're going to try to figure out here, okay? So I want you guys to kind of look at X. Pay attention to X. And as I move this slider, kind of watch where A ends up going. Okay, so we're still looking at A. When I get to 1, I think it's going to change colors. Maybe. There we go. So A is still this point right here, correct? Okay. Now I want you to watch where that goes, where it's going to match up. A matched up to what point? X, right? Okay. So because, so see that again. A goes to X, right? A goes to X. What that means to me is I'm going to take this letter X, and it goes in the first spot, okay? Because in the first naming, A has to match up with what it is equal to, or what it's congruent to. Does that make sense? Or what it corresponds to, what it matches to. So then I look at B. So what does B match up to? Okay, keep your eye on B. And it's going to go to what? What does B go to? It goes to Y. Okay? So I take Y, and I'll put that second, because now the second term here and the second term there have to correspond. Now I can keep doing this, but if I kind of develop a pattern that I started at X, I went to Y, and now where do I have to go next? I have to go to Z. So I'll pull Z up, and then I got to go to U, and then I got to go to V, and then I got to go to W. Does that kind of make sense to everybody? And now the question is, what does that mean to us? What does that develop for us? It develops a way for us to look at just the name, looking at just that right there, and I should know now what 6 angles are congruent to one another, and I should know now what 6 segments are congruent to one another. Does that make sense? Okay. When I look at the name, just look at angle D real quick. Okay, I think that's the one I've got here. If angle D is the 4th letter here, what angle is it going to be comparable to over here? Angle U, right? Well, if I ask this thing to show what angle U and angle D are they indeed congruent then? Are they both 147.01? Okay? We should be able to make that conclusion based off of anything up there. If I look at angle E, it should be congruent to angle what? V. If I look at angle Y, it should be congruent to angle what? B. Okay? Congruency is 2 ways, right? I can either look at the first shape congruent to the second one, or the second one congruent to the first one. It's just symmetric aspects of congruency. Okay, so that's nice. That's dealing with the angles. I guess those 6 congruencies of angles. Let's look at how this works for congruencies of segments. Look at these first 2 letters here, A, B. And actually, let me do it this way. Let's look at BC first. I think that's what I've got highlighted down here. If I look at BC, so do you see this dotted line right here? If I look at BC, where does it end up going? It goes to YZ, right? Well, BC and YZ, are they both the second and third letters in those names? So that gives me the relation that BC, I could write down now, BC is congruent to YZ. Can I say, I'm working this way, can I say that AB and XY, because they're the first 2 letters, they should be congruent? Okay, so those segments are congruent. We did BC. So basically what happens is if I recognize that AB and XY are congruent, now I'm just going to shift this box over 1 letter. So BC shifted over 1 letter, shift this over 1 letter, so I should get BC congruent to YZ. Keep doing that. Should CD match up to ZU? Okay, and again, kind of pay attention to CD. CD is this bottom one here. Kind of try to watch, keep your eye on where that's at. And it does match up to ZU, match up to that top one there. DE, UV, EF should match up to VW. All right, so we can write all these congruencies down. And now I got to shift 1 letter more. All right, and this is cyclical, right? It goes back to the beginning. So FA, think about looking at FA. Now watch FA. Where does it go to? It goes to WX, doesn't it? Okay, so the 6 congruencies, so we go through here and basically look at, there's 1 congruency, starting AB, 1 congruency, CD, or sorry, BC the second, CD the third, DE is a 4th, EF is a 5th, so I'd be having 5 congruencies written down. I got 6 sides though, right? That 6th congruency comes from F going all the way back then to the beginning of A. All right, so FA should also be congruent to WX. Does that make sense to everybody? All right. Now, why is that beneficial to us? I'm going to give us and we're not going to go through the work for this, or the algebra, I guess, to finish this problem, but tomorrow we will. I look at this picture right here, okay? And we're going to see a lot of these throughout the rest of the year, okay? A lot of different aspects of the course kind of bring in this picture or picture similar to this, and our goal is to solve for X and Y, okay? Well, you can kind of do what we did with the GeoGebra where it slides it and rotates and that kind of stuff, right? But that's going to be kind of hard. What we can do, though, to make it a little bit easier, is say, okay, I'm going to look at one of these components that has X in it, okay? So you guys recognize that GH has X in it, right? So look at my name up here. They're telling me this, and they normally will tell me that. Or they'll tell me somehow with my picture of how I can create that. Okay, so they'll either explicitly provide it like they did, or imply it with a picture. Okay, somehow though we can develop that. So look at that. The GH has X in it, right? I know that's a segment, correct? And if I'm looking at the picture on the left, the only segments that I have are 8 and 10, correct? Now I could, if I'm not sure what to do, I could take a 50-50 guess. It's that 2x minus 3 equals 8, or 2x minus 3 equals 10, right? And if I'm lucky, I get the right answer. But I'm not going to be able to do that every single time. You get lucky, right? So, how do I do it? Well, I look at GH and my congruency up here, and they're the last 2 letters, right? Yeah. What should that relate to then over here? Last 2 letters there. So GH should match up to LM. And now do I know that they're congruent, right? Okay? Because that's what those kind of corresponding components tell us. Okay? So I can now take 2x minus 3 equals 8, and I got an equation to solve for x, right? Okay? And then we can do the same thing for the y, 7y plus 9. Angle E is going to match up to what angle? N. So I take 7y plus 9 and set it equal to 72, and now I've got my equation solved for y and x, right? Okay? And that's usually what they're going to do. Obviously, it's a lot easier, and sometimes we'll do this, and it frustrates the heck out of me when they do this because they're taking all thought out of it on your part. Some will do, cursor's being slow. Some will do this. Pretty obvious what I have to set 2x minus 3 equal to now. Remember, we got one option, right? And the other thing they'll do is they'll take, they'll wipe this one away, they'll wipe that one away. Well, if I'm, in third grade, I can probably figure out what I have to set the equations up at, all right? So I think it's in regards to kind of deciding and distinguishing whether we know really what's going on, it's nice when they give us kind of these extra parts that we don't necessarily need to solve the problem, okay? So all of that, guys, is explained here in this slide. That's why I like, I think GeoGebra says so much more and allows us to recognize things so much better than when I was just able to produce this in front of everybody and say, yeah, this should make sense because A is red and E is red, so they match up. B is blue and F is blue, so they match up. Okay? Where the GeoGebra idea of being able to say, okay, how can I get that shape A, B, C, D to match up with the shape F, E, H, G? And when I overlap them, what angles match up to what angles? And my hope chart you guys see here, the shape on the left is simply kind of a reflection over that line of the shape on the right, correct? And the only way that these two shapes can match up is if the red A matches the red E, right? So they put the red A first, the red E first. And then they say, okay, the blue B is going to land on top of the blue F when I fold on that red line. So I guess, is that blue? Blue, okay. So blue and F. Oh, I was like 10 years ago. 10 years ago. Just because I got 20/20 vision, that's just focus. That doesn't mean I'm not colorblind. All right, so B and F are congruent. Now C, guys, color's that? That is purple. Yeah. All right, so C and G are the third letter, and then D and H, okay? Because of how those two shapes have to lay on top of each other. And then obviously corresponding positions are going to show us in this congruency statement that those parts are congruent. So it shows me that because A and E were both the first letters in this congruency statement, I'm saying these shapes are congruent. So then what I gain from that is that these individual corresponding parts are also congruent. Does that make sense? Okay. So that's what's laid out here with these 8 congruencies. Okay. And what we talked about with that one in GeoGebra. Okay. The benefit of knowing that, guys, is that when I get a problem like this and they give me this picture, okay, a lot of people are going to struggle saying, okay, what does K match up to? Because when I look at that, I've got options. Does K match up to O? Does it maybe kind of looks like it might match up to M? Okay, and the more kind of confusing your pictures look like, and the more similar they are, okay, what I mean by that, go back to what I had here earlier when it was, maybe more like this, okay? It's kind of hard to see which ones really match up. Because when I do that, they're close, right? So visually, when they're apart like this, it's hard to see that BC does not match up with VW. But if I do indeed have this statement here, now I do know that A and X do match up, right? Okay. Without having to rotate and translate and flip and all that kind of stuff in my shapes, if they give me this phrase right here, I automatically know what I should set congruent to one another, and then that's going to help me build equations when we start practicing stuff tomorrow and the next day with our algebra. Does that okay with everybody? So when I give you the congruency statement, you should tell me, in this case, the 8 things that you know to be relatable. Okay. That being said, so let's say that we've got, let's say we've got this just A, B, C, D is congruent to E, F, G, H. What if you didn't name it that way? What if you were first that said, I named it C, B, A, D? Well, from C, is this okay? Is C, B, A, D okay? C to B to A to D. Does that trace out my shape? Yeah, so that's okay. Now, what would that be congruent to over here? Now, you can go back to the shapes, or you can say, well, maybe I've already got that one in front of me. You start at the third letter, right? So what do I have to start with over here? Third letter. Okay? And then you start at the third letter, you went to B, right? You went backwards to B. So third letter, let's go backwards to F, right? And then go to E, and then where do I got to go? H. Do those, think about the way I've written it. Does it still say angle C is congruent to angle G? And that's what that said right there, right? Does it still say angle B is congruent to angle F? C. B was congruent to F when I wrote it this way, right? Does it still say A is congruent to E? And does it still say D is congruent to H? Yeah, okay? So, regardless of how I write it, as long as I abide by the rule, the corresponding parts have to match up, I'm still going to get the same 8 congruencies over here that maybe somebody wrote it this way would get. Does that make sense to everybody? There are 8 different ways we can name that thing. So there can be 8 different congruencies that develop. But of those 8 different congruencies, each one of them should produce these things right there. Okay? And that's what I want you guys to understand, is that when we're going over something in class, there's a lot of different ways we can name, a lot of different congruencies that we can use. But there are also some congruencies that we cannot use. All right? And because there are so many that we're allowed to use, a lot of people kind of just say, oh, I can do it any way I want to. And then that gets them in trouble 30%, 40% of the time. Okay? So you cannot just haphazardly choose your letters any way you want to. Okay? Even when I'm naming the first one, because naming the first one, you do have a lot of freedom in naming the first one. Okay? Can I name the first one BDCA? BDCA. Remember what the name should do. It should set out a path for me to trace the same shape that I'm interested in. If I go from B to D to C to A, does that trace out the quadrilateral that I was interested in? No, it traces out that red set of segments, whatever they are. It's not a shape anymore. It's not a polygon. Okay. So this is not a valid way of naming it. Okay, and that's what I need you guys to understand, and it's something that people struggle with a lot. Is that even though there's some freedom in the way we structure our names, you don't have complete freedom. Okay. All right, so here it says, on the triangles congruent, justify your answer. Okay, so right now, we have to do some work. Okay. Tomorrow, probably not tomorrow, but maybe more like Monday or Tuesday, we're going to be able to better address this and basically say right off the bat, just by looking at, yes, those are congruent. Okay. But right now, we have to do a little bit more. Right now, I have to be able to say, angle A is congruent to what? Angle E. I have to say angle B is congruent to what? Angle D. Okay? Now, I can't say angle C, because when I look at angle C, I'm looking inside that circle, right? Yeah. Are there a lot of angles there that have C as a vertex? Okay. So I can name it with 3 letters, though. So I'm going to say angle BCA. Would you guys agree that that's congruent to angle DCE? Okay. Why? I don't know. Why is that angle right there? Vertical. Yeah. Here's that one, the vertical. That's probably the most obvious way. There's other ways. We'll just leave it there as vertical right now. So that's good, but that's not enough to say these 2 shapes are congruent. we then have to say that AB, segment AB is congruent to segment what? ED. What about BC? CD. And what about AC? CE. So those are the 6 things we need to justify, that we need to come up with to say, yes, these 2 shapes are congruent. Okay? Now, when we name them, and we're all going to write what we call a congruency statement, I'm going to name one of these triangles. It doesn't matter which one you start with. Which one you want to start with, the one on the left or the one on the right? Okay, left, okay? So now, let's start with letter C. All right, so I'll start with letter C. Now, where do you want to go from there? Okay, A, and then B, right? That's my only option. If I went from C to A, I can always finish at B, okay? If I name it that way, it will be congruent to. Now, if I start at C here, and this triangle on the left, we'll have to start with some triangle on the right. C. Then I went to A. A has 1 mark in it, right? Where do I need to go in the triangle on the right? E, and then finish where? D. Okay? So that congruency is how I would kind of explain this. Okay? Or write my congruency statement for these 2 triangles. Now, if I wanted to maybe rewrite it, maybe I wanted to go A, B, C. I went A to B to C, right? I started at the middle, went to the end, came back to the beginning, right? So wouldn't that be EDC here? All right. So that's kind of how you would check. If I use ABC in class, but you use CAB, that's how you would check if you're on the same page as me and not. Okay. What that does, guys, I'm just going to talk about that top one. When I write this top one, it is effectively giving me these 6 things. Is that all right? So if you had the option to tell somebody that they have 6 congruencies, would you rather write those 6 individual congruencies out, or would you rather write it this way? Yeah. You would write it this way, right? That's more concise. It says more information with less words or less notation. Okay? But when I see this, when I see that, it provides me these 6 things. And when I see these 6 things, it also provides me that. So it's a 2-way street here. Predominantly, we prefer this one. Now, here's something I didn't talk about. Okay? When we talk about triangles, we have to put the symbol up front. You know why? Okay, but why can't I just, because if it's a pentagon, I don't draw a little pentagon out front. If it's a dodecagon, I don't draw a little dodecagon out front. Okay? If it's a quadrilateral, I don't draw a quadrilateral out front. Anybody know why I have to do that here for a triangle? Absolutely nothing to do with 180. Close. So the idea here is that when I don't put that triangle up front, it accidentally classifies it as something else, like based off our notation of how we name something else. It's not the angle, though, but it's the same reason we had to put the angle out front of an angle, when I name an angle by three letters. If you remember back to when we identified what a plane was identified through notation as 3 points that are in the plane, right? Okay? So when I say CAB like that and I have no information out front, because we first set our rules for identifying planes first, that's the process for naming a plane. So if I say CAB, people think I'm talking about plane CAB. Going back to the idea that if I was in a course that just used text and no pictures, and I said CAB, then I know the person reading the text is talking about a plane. When they put the triangle up front, now I absolutely know they're talking about a triangle, right? Or if they put an angle up front, now I absolutely know they're talking about an angle, correct? Okay? So that full describer out front isn't just because it's fun to do or it's just cute to do. It's because without it, I'm referencing something completely different than I want to, or that I want to talk about. Is that all right? When we look at this stuff, guys, so just using another example here, you know F is congruent to what? D. What are those? What is F and what is D? They're angles, right? Okay? So angles are referred to as parts of our triangles, correct? What do you know about those 2 triangles? Well, they both have 180 degrees in them, but what is the relationship between one another? They're congruent, right? So you just told me that F and D, because they were in matching positions, right? What's another word for matching position? Starts with a C. Corresponding, okay? So you just told me that corresponding parts of those two congruent triangles are what, Torno? What was the conclusion you make about angle F and angle D? They're congruent, okay? So you just told me that corresponding parts of congruent triangles are congruent. Does that make sense? So those, I deleted it, those 6 statements that we came up with here, when we wrote those out, or maybe the 8 statements that we get here, okay, those, developing those off of this statement here, or developing the 6 that comes off of this statement here, comes from the phrase, we use the phrase corresponding parts of congruent triangles are congruent to refer to those 6 or 8 or 10 or 12, however many individual congruencies that we can develop. Does that make sense? Corresponding parts just means matching parts. Could be angles, could be segments. That's what parts is kind of referring to. Okay? Of congruent triangles, meaning that the triangles that this information comes from were set out to be congruent at the beginning. Those individual parts then are also congruent. Okay? Now, it's a phrase that we're going to use a lot. We're going to see it in our proofs a lot. We don't want to write that out a lot. Okay? So we abbreviate with the acronym CPCTC. Okay? We use it a lot. You'll hear me say corresponding parts of congruent triangles are congruent. It's a very, very, very important concept that helps us build relationships between triangles and other shapes. Okay? Without this, we struggle kind of progressing into other shapes. All right? Tomorrow, guys, we'll finish this up. We'll do some examples. There is an assignment online, 4.1. It's open. It's not due till Monday. Okay, so you'll have quite a bit of time to work on that. You could probably get most of it done tonight, but there are a handful of examples that incorporate some algebra.